I'm not sure if I mentioned, excuse me, this in another video before, but this is the lathe motor mount that I'm designing. Now, essentially, these are made out of aluminum. As you can tell, it's going to have holes. This one will be counterboard, so that let's see here. What did I do with it? Hang on. Found it. So this can basically, this will sit on the motor, and this will go through like this and be, if not flush, just countersunk a little bit. And then there will be threaded holes here. That's these. That way this can sit mounted up to the steel plate for the lathe, and then this can drive the spindle for the lathe. That's the plan anyway. Well, this is essentially where this motor mount is going to be going, except on the back side. This is the top. I'm just trying to line up the holes basically, because I'm going to have to drill the holes through this 1-inch plate. I got to tap these holes, and then I can run the pulley belt system to the spindle for this lathe. It's getting there. I'm on the last one now, on the last mount. One more and we'll be good to go. You've seen this before. This is the spindle for the lathe. I know it's a baby, whatever. It is what it is. The chuck goes on here. But now, as you know, I'm working on the motor mounts. So the spindle is going, the motor is going to be down here. Pretend this is the plate. And there'll be a belt coming up to this. This is what's going to turn it. So, you know, the question is, I'm having a hard time with whether I want to run a belt to this shaft or do it direct to the spindle itself. If I do it to this shaft, I've got the high and the low, which whatever is what it is, I don't care. It's just a matter of how to tie it in. The motor is 8,000 RPM, so I do have to make sure that, you know, this is geared down somewhat. So I would have to put a small pulley on the motor. Let me see if I can turn my light on here. There we go. Now, I could get rid of this and put something in here to drive it. Again, I'm still kind of pondering the best way to do this. I do think for the time being, I'm going to try to keep this system. It just seems like the most logical thing to do, on top of the easiest thing to do. But, I don't know. We'll see what happens. In any case, the machining for this stuff here, I put at the end of the video, just a couple of clips. And up next is the 3D printer part that I was talking about. So, hopefully you enjoy. See you guys. I got this off the internet. This is a hot end for a 3D printer. I've got multiple 3D printers laying around here, just basically parts. You know, I have the one I use, and then I have the one I converted to an EDM, but I also have another one on the shelf that's just sitting there. So what I'm going to do is I'm going to convert that printer into one I could use for better filament, you know, like maybe polycarbonate or nylon, because for those filaments you need a much hotter temperature. So that's what I'm working on at the moment. This is a visual of a regular standard heater block and nozzle. See, the Teflon, you can't have the Teflon that's inside of this threaded screw here, because the Teflon at the temperatures that will melt polycarbonate will literally start to melt the Teflon, and then you get toxic fumes and whatever. So it has to be completely redone, and this is what I'm going to aim to make. I figure I got the 4th axis, should be a fun project. So let's see what happens. I set up my 4th axis to do this part. The reason for that was I was trying to do it where I could set it up to do multiple parts at once. I'm not sure why. Alright, now we got to drill a couple holes here on this edge. Alright, this is the hole for the heater. This is the hole for the injector. This is a set screw, and that's a hole for the thermocouple. So we're getting there. It's going pretty good.